So he's just basically told you the same thing again, that when you find the gradient of a linear line, you will see that will be a constant, and this constant is basically what it means, that it is not a multiple of x, it is some value and there is no multiple of x with it. However, when you found the gradient of this line, you found the gradient of this line was 2x. So your change in y or change in x was 2x. This is not a constant, this is some multiple of x. So this is the only difference he's trying to tell you. Now, why did he tell you all this? He was telling you all this to give you the basis for something known as calculus differentiation. So for example, when x is a function of just 1, let's say the equation of the line is y is equal to x. So your rate of change would be 1. When x is a function of 2, which means that it's x raised to the power 2, which is something that you've solved here yourself, which is y is equal to x square. You saw that the gradient of this line was 2x. The rate of change in this case was 2x. Whereas in this case, where you saw that the line when you had y is equal to x, where can I get y is equal to x? Yeah, when you had y is equal to x, as y is a function of 1, 2, 3, 4, the gradient of this line was a constant. So when you have x raised to the power 1, you get a constant value. When you had x raised to the power 2, like in this case, your gradient was a multiple of its power, right? Now the same thing here. When you see the gradient over here, you'll see, the rate of change. So when you see when x is to the power 3, you'll see the rate of change is actually 3, which is this 3 over here, and x is a multiple of it, but this time raised to the power 2, but we'll discuss that later. But what he's trying to basically tell you is that every time you have a higher value of x, as you go proceeding on from x raised to power 1, you'll see you will get 1. When you see x raised to power 2, you will see that the rate of change will be 2 and a multiple of x. When you see x raised to power 3, you'll see the rate of change being 3 and a multiple of x. When you see x raised to power 4, you'll see the rate of change as 4 with a multiple of x. When you see x raised to power 5, you'll see 5 and x with a multiple of 5, and x raised to power 6 would be like basically x multiple of 6. He's just trying to establish a trend here. And this trend is basically going to help us dive into calculus. Now what he's trying to say is that if you look closely at the relationships between the top expression and the bottom expression, you may be able to see a pattern. And the pattern is this, that whatever you have, your raised to the power, that raised to the power is something that gets multiplied with x later. Now just take a look at this table, try to see the pattern here, and we'll move on in the sense that I'll explain to you how he's done these calculations. And this is how he's done these calculations. I gotta go pee and pause this.